Hey team, it bothered me and I really wanted to figure out why it was different, and I figured it out. But one of the things I realized is that it is true. It actually doesn't matter which way you approach it, you still get the same answer. So method one, this is how the cows would have done it, where you would have done x to the power of -1 and you take out half as a constant instead. So then it becomes log e of mod x. And if you follow that through, you should end up with this line. And if you type in your cows, you should get 6.462, right? So I think that's what the cows would get if you found the average value from that step. But say you were asking, well, what if it was 2x to the power of -1? So instead of separating that half, instead of separating into half times 1 on x and then bring this x up, what if you just brought it all up together? And that's where I was saying that it should be the same, and it is the same, but I'll tell you where it is algebraically as well. So let's say we now have ln of 2x, mod of 2x, and you plug it all in. The difference here is that this would be mod of 10, that's mod of 4, and you'll find that if you plug that in correctly on your CAS, it should be exactly the same. So if I zoom out, both answers are exactly the same. So you might ask, well, why is it the same? And the logic is here. And I just remembered this as I was going through it. So when you antiderive 1 on 2x dx, right? Yes, if you took it as antiderive of 2x to the power of -1 delta x, then technically that is your a value. And then you would say it's 1 on 2 log base e of the mod of 2x, correct? But remember there's that plus c. And this is where it's key. So in an indefinite integral, that plus c, we don't know what that extra value that is missing. So this 2x here, another way of thinking about it is this is actually the multiplication of 2 and x, true? So in our log rules, log e of 2 times log e or with the x can be actually broken up into log e of 2 plus log e of x. True? So what that means is, what you're saying here is you could actually say it's the same thing as saying half multiplied to ln of 2 plus ln of x. Okay, and the thing is, when you multiply half to this, that's going to be a constant. So half ln 2 plus ln of x, and then remember that plus c. The plus c and this constant value can be combined and just be called c. So it ends up being log base e of x plus c. That's why if you've taken the other approach, so versus, had you done it where you took out half and then you integrated or antiderived 1 on x, you would have ended up with half ln mod x plus c. This is the same. Oh, sorry, I forgot to do the half to this one too. So there we go. That half ln mod x plus c is equivalent to what you guys got. And it's proven that the average value is actually the same as well. So it actually doesn't matter. But to show the mathematics as to why it works, it's that split, it's that plus c. So you're right. Like, how do you know? Well, either way, it would still work. I was just baffled when I heard that the answer was different, but actually the answers are the same. So hopefully that clarifies that when you write half ln of mod 2x plus c, this is equivalent to you saying half of ln mod x plus c. And the proof to it, as I said, you can break that up and it becomes half ln of 2 plus half ln of x plus c, but these two can actually be combined to be just c. That's why these two equations are equivalent. Okay? In a summary, in a nutshell.